But
Okay, so basically, I'm going.
sorry, guys.
I'm just going to introduce the problem here, and I'll discuss one of the solutions which we've come up with. Brainstorm over something can be further done, or maybe it does not even need a solution. That would be perfect. Uh, so problem, that's the agenda. That's how I'll move forward. Just focusing on resource management. So there are issues when we're trying to partition hardware resources. The application in case here is Oracle database, which uses pluggable databases to provide multi-tenancy. Uh, Oracle, basically pluggable databases are the containers of the Oracle database world. Um, there are issues when basically consolidating on common hardware, which is to get the performance isolation while still utilizing the hardware to the maximum. We need something in mixture of cgroup shares with exclusive CPU sets. Exclusive CPU sets give you the cache affinity you want, but do not utilize the hardware fully. Cgroup shares will give you uh, the utilization of the hardware when other things are not running, but they don't give you the cache affinity. So towards something dynamic, basically that's what you want. You want to share the CPUs opportunistically and rehome to the assigned CPUs when the load increases. So basically, let's say the other sets started using uh, their set to the maximum. You want your thread, which is right now outside your set, to come back to your. That's what I'm calling rehome. So in summary, basically, as I said, we want cache affinity of exclusive CPU sets and work conserving nature of CPU shares. That's what we want. So these are the requirements to support multi-tenancy, be work conserving, and have a programmatic interface to do all of this. We were thinking of extending sketch setup in P by introducing another flag and saying that there's software affinity to it. Maybe there are other ideas, but that's just one of the things which we have tried out. I'll just show you some preliminary results. So uh, this is Hackbench data. So hard set is when you use exclusive CPU sets. No set is basically you're just running vanilla scheduler, and soft set is basically when you're using this soft affinity interface. And the results are the number of this is on 8 socket machine, um, and using 40 threads for Hackbench, and each of these are basically geometric means of all the number of groups which are running. I tried to vary it from 1 to 8, and that's with 80 threads. So basically, what you want is till this point, follow this curve of unbound. That's the intersection point, and start to move towards the hard set as your utilization increases. That's what, in part, what we're achieving. Is what we want. Ideally, what we want is exactly follow this, but we are close. It's not exactly following that line.
Not even halfway. Yeah, but it's still better than where we were, and that's actually a big deal.
So you want something which would be ideally just suddenly understand that you actually want to adapt and fully partition the system, but that's hard to. You want you want right?
Yes,
That's the ideal. That's the ideal solution. If
you're not going to get that.
had that existed, yes, you want exactly this minimum curve to follow. But if you have only one policy which you can put in place, then this kind of gives you.
And you said this is an 8 socket,
This is only.
and this Autonoma not help with it.
Autonoma kind of helps with it, but it's still the threads when they mix, then it kind of becomes hard.
The other problem with Autonoma is that sometimes decides to pull memory over to another node, and that's not a good thing. We don't want that to happen.
Well, look at improving that.
That is one possibility. Yes.
Let's talk about that. Basically, this was Hackbench. We are working on getting Oracle database to modify its own application gathered those numbers and probably set up another RFC. Uh,
And I think that the reason Autonoma is not a great solution for this is the whole bit here is that we know where we want to keep memory. We can always use CPU sets and say, okay, this is the node you're going to live on and not migrate you over.
Well, no, if you're talking about memory, the interface is unbound, not set CPU affinity. And if
Hold on, hold on, hold on, hold on. I'm not done. So the memory problem can be solved, right? The thing is that we want to expand out of the smaller set that we have fine tuned when the system is not loaded.
but regular load balance does that. But Autonoma should get you back to your memory. And if it does not work correctly with mbind, because if you say we know where the memory wants to live, then bind your memory there. And this should avoid the migration, because if you mbind it, it cannot migrate the memory off. And therefore it should then pull the task towards the memory. If this part of Autonoma does not work, we should fix that.
we tried that. No, we not tried that one. But so how do you? So you're saying this just run vanilla without any affinity and
When I use mbind,
no, that's for memory. What I'm saying for threads, you have no affinity, and basically the scheduler by itself will put it close to the memory.
So I have not explicitly looked at Autonoma for a long while. So the idea of Autonoma is that you group memory and the tasks that use it together. And Autonoma will actually migrate your memory away. But if you bind the memory, it cannot move it, and therefore it should move the tasks towards it. If that part is not working,
Okay, so
because if you don't give the memory any chance to get moved, it should still prefer to move the tasks close or at the same node
I mean,
where the memory
okay,
is.
so
the other problem with Autonoma is it doesn't work as well as advertised for most of our use cases.
Well, then look at that.
Yes, no, people are looking at that. They're not, it's not as, but what I'm trying to get to is it's disabled by default in our kernel.
Well, I can help that.
Sorry.
That's out of my hands.
No, so other thing which let's say it's always trying to schedule it there. Now let's say overall system is underutilized, but now this socket is fully utilized. Would the scheduler then put threads outside this?
It should, yes.
And when the load increases outside, will it now try to put threads back?
So
That's the
when will the
that's the
migrate
idea.
back
that's
to
the
the
bit
node
which is kind of hard. Like how do you rehome them when the load increases on another part?
So with Autonoma, it typically tries to always run a task near its memory, and if that doesn't work, it tries to migrate the memory towards where the task then end up. If you pin the memory with mbind, this cannot happen. So, but at the same time, the load balancer tries to not overload one node and will migrate stuff away when they're idle. So this would then give the exact behavior you're looking for. It will spread out
when
if
it
there
is
is
idle,
idle.
but then how quickly will it come back?
Yeah, how
When
quickly
will it migrate it back when the load starts going up? How quickly does
Thereabouts.
that happen?
I mean, to have a look. It should do it pretty quickly. And I mean, Autonoma seems to work for a fair number of workloads. We've run the HPC stuff, and there's the Java Beans bullshit benchmark. And the people are running quite a number of workloads on this, and I think Melbourne recently poked at it again to improve it a little bit, and we're not horrible anymore. It does get improved, and it's working for a fair number of workloads.
Experience suggests that once the thread has moved out, it will take a while to come back.
Well, yeah, it depends on what your expectations are, but again, that is something you can work at to try and get it back quicker.
So the point is, how do we have that specification that we prefer this socket? Like we always wanted to start searching for CPUs from this. That's the essence which it captures.
So that's in the NUMA It's in the memory locality information that the Autonuma has. So when it um, migrates tasks, it always tries to improve the locality from where it found that the memory was when it looked at it last. And it's typically constantly scanning, where's my memory, where's my memory, where's my memory. Of course, if you find it, it'll always be where it should be. Um, and so when it migrates, it tries to improve the locality if at all possible. But otherwise, if there is idle, it's not possible, but we'll try and keep the idles if you will.
So I think the important question that we have to answer is how quickly does it bring it back to its home node?
Well, not only answer, it's something you can try and improve.
Right.
Yeah.
But if the memory of the process is in that socket, the task will come back to that.
Eventually it will come back. That's not the point.
That's
is,
not the problem.
The-
You want to
start-
how quickly
The frequency of scanning is tunable. I don't recall.
Yeah, but if they unbind it, the frequency-
Unbinding is too aggressive.
Well,
You have to
it's what
unbind
they
it.
want. They want to
you need
unbind
to
it.
unbind it.
But then the frequency of scanning becomes irrelevant because it'll always be where it was.
So then the question is at what point in time does the load balancer decide to bring it back?
I don't know the numbers. I need to measure it, but
Right, that's exactly
let's
what
measure it. I mean, it will come back, and I would say reasonably quickly, but I don't have a time scale. I don't know your application. Let's make the experiment.
Also, what about subnumber partition?
You're running an 8-circuit system. Is that
This
really a
is-
concern?
No, this is just one use case which I'm showing, and there are subnumber partitions as well. You have two sockets where you're running 4 pluggable databases. Then you still want to divide that system, but not exactly cleanly partition it, but allow those threads to move around. How do you?
But for what are you optimizing now? They're already sharing the L3.
But
So how is there really a
they're
form
sharing
of
L3, but
link?
probably still not sharing L2, and
L2 is per core, so no,
they're not sharing L2, and then so that is exclusive, and then you still allow those threads to run outside its set because now you're utilizing that hardware fully in terms of threads. So that's a problem that can be solved in certain operations with this one.
Okay, no.
I mean, that's I'm
Yeah,
going to do
we're
anyway.
waiting on the database.
We're waiting for the application to change, but in the meantime, I could run the hack then. Because at least the trend is showing what we want actually quantify on the inflection point, try to follow the hard steps if it can. as much as it can.
Yeah, so I'm not sure how much performance gain there's to be had inside of a node, but the actual numbers for inside one node.
I can show you 2 sockets for partitions. And that will be a subnumber partition. Questions, ideas? No.
So Autonuma is the way to go.
Definitely for the
At
big,
least for
for the big games,
sockets.
yeah.
But if when you consider those subnumber partitions, then probably have.
Yeah, but then the question is what is the exact performance?
Because for cross node, it's an obvious win.
Yes.
Within a node, it's not immediately obvious how much gain there is to be had.
There are claims and on some of them.
Who has tried
The database guys have tried it with some other ways. But they claim.
Okay,
You're
so you get the answer there. Apparently, they have tried it on other OSs.
They have tried it, but let's try this one.
Yeah, because I think that will be a natural and good extension of Automata.
If it's things work.
So what would be the exact extension? Coming back to the home node, I mean, if you have mbound
Just making sure that mbind combined with Automata actually works. But I'm not sure anybody is actually doing that. Mostly Automata is sort of placements for both memory
Right.
and tasks.
Right.
And here you have a fairly accurate view of where you want the memory to be. And I'm not sure anybody is actually doing that. So it is one, validating that unbind combined with Autonoma works,
Right.
and then see if it works good enough for you, and then see if not, try and improve it.
But then I'm not sure how quickly we really want to be moving back to the home node for a general use case. Let me put it that way.
And that's where you get to run numbers with all the other Autonoma users. See what it does.
Yeah.
See what it does.
Together it's very specifically for the subdomain.
Specifically, let me know how much you can actually win and why.
Okay.
You? You have to give batteries.
That's it. That's it. Oh, good job.